So, yes, lots of this information either ends up in the calculation, some of it will end up in the actual EPC itself or some of the outputs. And a lot of these, as you can see, are drop-down menus. The type of terrain will have an impact on the shelter factor, which I didn't mention actually under the infiltration rate. That's a correction. You can imagine if your dwelling is densely packed by other dwellings and trees, the impact of wind speed on it is less than if it's on top of the hill in Orkney, where you won't find trees. And similarly, the shading has an impact on the solar gain. If I remember rightly, you define the number of sheltered sides, etc.
Sorry, you mentioned the correction factor. Is that one of the elements that will go in towards?
No, well, the correction factor, when it's used for the energy correction factor, no, that's just a number that's revised between SAP variants based on, I think it's based on energy costs, or it's possibly a last-minute fudge on, right, it's going live tomorrow, what correction factor do we need to apply? Last thing that Brian calculates, probably. You can obviously add theoretically an infinite number of floors. I mean, one of the problems with developing SAP software, and I've worked with some guys who have been trying to do that in the dim and distant past, is you can add an infinite amount of information. Now that is doable with software and online tools, and the reality is you will always get to a finite amount, but you could add more floors. I mean, there's nothing in the regs that says you can't have a 600 floor house. And of course, as soon as you say, well, we'll just make it 10, eventually someone's going to come along with the 11th floor house. So it makes the way these things are structured quite difficult. And because part of the requirement of the software is it follows the spreadsheet in the SAP document as well. And I meant to bring a copy along. It's downloadable. It's a free download. It's a 200 and something odd page document now, and it does include a worksheet or a series of worksheets, and the calculators are intended to follow those worksheets, which becomes very difficult when you get to worksheet 3 or worksheet 8, and it says, right, take this input and put it back into worksheet 3. And there are bits in the methodology that will say, right, now that you've calculated this bit, go back and calculate that bit. And it just drives people nuts if they're trying to write a bit of software. So basic dwelling dimensions. Average height. The height is a good one. Back to this, if you've got a complex room in the roof, the only way you can work out the height is to work out the volume and divide it by the floor area, assuming you know the rules of what's floor area and not. You then put the height into the calculation, which immediately then just multiplies it back by the floor area to use the volume, because it's interested in the volume in terms of how the ventilation rate acts upon that volume. So the bigger the volume, the more air you're going to lose at whatever the ventilation rate is, or the air change per hour rate. Oops. In Scotland, the 2012 should kick in on the 1st of October 2013. It's always good that they coordinate that. So here we have thermal bridging now. You could use a default, and the default assumes 0.15, and that is the 0.15 is multiplied by the overall dwelling volume, and is then expressed as kilowatts per degree centigrade heat loss. So it just adds more heat loss. Or you can go through and calculate each of your thermal bridges. So you've got a lintel, for example, and a sill, and that's measured along the length of the actual opening. So you don't take into account the rest at the end of your lintels, it's just the opening. And you then use a psi value. The psi value can either be taken from a set of defaults, or they can be taken from an accredited value. However, that accredited value can only be used if you're using robust details. So, and in Scotland, we very seldom use robust details. That's an accreditation scheme for those who don't know. Or you have to calculate the psi values, or you can use the psi value from the accredited construction details bracket Scotland bracket guidance, which is also published on the Building Standards website. However, there is an argument that says you've got to follow those details precisely, which means you're restricted to a narrow form of building construction. But increasingly, more and more, certainly our membership in the RAS certification scheme are looking to do these calculations in more and more detail, because you'll reduce the thermal bridging value at the bottom, the 25.038, which is kilowatts per hour additional heat loss. And depending on which thermal bridge you're looking at, you start getting quite extensive edges. Passive house has a completely different philosophy. Passive house, one of the things that the SAP calculation does is it measures your envelope through which you are losing energy as being the internal surface of whatever that construction is, i.e., that face in this room is where we're losing the heat. What Passive House does is they take the area as being the external surface area, and they multiply the U value by that. And because they do that, they argue that they overcompensate for the thermal bridges at the corners. So whereas we're saying that's my internal corner and I know heat's going in that direction and it can get out, they're saying that's their external corner. So anything coming this way, would either have gone that way or that way. Which on one level it avoids them having to calculate thermal bridges. But it's one of the rare areas where it's diverges from a SAP calculation, and therefore you can't use it for compliance. They also have completely different assumptions about the amount of appliances that are going to be used, which has two impacts. One, it reduces the overall energy load, and they look at that rather than the way SAP looks at it, but also you've then got less internal gain from all those appliances. So the thermal mass, you can simply choose a default based on the type of construction. So 100 kilojoules per square metre would be timber frame, high would be high masonry construction, or you can actually calculate it by documenting all the thermal mass in the building. It does have an impact on both DER and TER. So if I move to high, for example, and submit that, so this building's not compliant at the moment, and if we've got time we'll play around and make it compliant, but the TER is 19.58. We submit that. Sometimes you have to move to another screen to, so did that change the DER? Yeah, didn't change the TER. That's interesting. So it's had an impact. I thought that was going to change the TER as well, but obviously not. We've got a series of exposed elements. So we've got our ground floor, we've got all their walls. When I do a SAP calculation, I tend to do all the walls individually. You could theoretically just munge all those together, because this bit of the calculation is only interested in the external wall surface, and its orientation doesn't have an impact on how much heat goes through it. I do it separately simply because when you then get to openings, and you can theoretically munge your openings together orientation by orientation. I've got one big window facing south, one facing west. I actually, whilst it can be a bit more laborious, it pays dividends if you've got multiple houses that you've got to change the orientation of. So I put every single window in and I put it in the wall it's going to be in, so that if I need to replicate and change the orientation, I can do it with the brain turned off to a certain extent, which is how I mainly operate. So there you have every single window. You pick it out of a menu of windows that you've developed, and you give it its height, its width, and its orientation, and a specification. So the specification, if we have a look at, say, a specification for a window here, that's a door. Again, there's all sorts of rules of when a door is a window and how much glazing it needs to have before it's a window, because then it's got some solar gain. But if we look at a window, you've not just got, oops, clicked the wrong one, sorry. You've not just got its overall size and its U value, you've also got a frame factor. So how much of that window actually is glass, how much is just frame. And we're now seeing, again, as a refinement that if you've got the U value for a window is tested in a hot box, but it's tested at pretty much a standard size. So if you have a range of windows from one manufacturer that diverge from that, it can be enough to change the U value window by window, assuming that the frame and the glass has got a different thermal resistance to it. And you also got coatings on windows, and that gives an indication of how much solar gain you'll get from those, as well as having an impact on its U value. You then have primary heating. You can now have two different primary heat sources, and you can populate that from a number of sources. You can put in manufacturer's information. You can use a SAP default value, or you can drag information in from the UK boiler database if you've got a specific boiler and you've got a specific, you want to use that specific efficiency. I won't do that because dragging stuff in from the boiler database takes a long time. But alongside that, you can also change your controls. Closer to the bottom of the list, the more efficient. You can change the faction, so if you had two systems, you might have 60% on one boiler, 40% on another. You've got all sorts of controls. Let's have some delayed start, and let's put enhanced load compensation, and let's put air pump. If we put air pump inside, then you get 10 kilowatts per annum of additional internal gain, which is then multiplied by your gain loss factor, so you don't necessarily get all of it. But if I update that and close that window, we should have seen, did we see a little improvement? I didn't improve it much. I won't install, FGHR is a flue gas heat recovery unit, which would give you an improvement. Let's see how quickly I can install one of those. It's an oil boiler, so they don't do them for oil boilers. Secondary heating. At the moment, we've got a secondary heating system. What I'll do is I'll take that out. A log stove helps your DER calculation, because as soon as you say you've got secondary heating, SAP assumes 10% of the heat requirement is from that source, irrespective of where you've put it and how effective it might be. Putting in a log burner helps your DER, because I was displacing some oil with wood logs, which has got a lower CO2 emissions factor. So if I submit that, and let's go back here, that's still, nothing I'm doing is changing the DER. That's quite strange, isn't that? Wonder why that is. That's very interesting. Usually it would. I will get this to comply at some point.
Install a heat pump. That's it.
Is the target building assumed to be heated by gas?
No, it will be heated by the same fuel. So if we, for example, if I deleted that heating system, and I'll put one in, but I won't do it through the boiler database. I'll put it in as gas. That's kind of your default. Let's make it condensing. We'll give it some good controls. We'll throw all the controls at it. Boilers tend to be interlocked anyway. Definitely yes. Definitely yes. Oh, definitely yes. Yeah. And definitely yes. It should change the TER unless something's happening in the software. We'll give it 100%. That's very strange. I'm not quite sure why it's doing that. I hope there isn't a glitch. Yeah, that should have changed the TER to a completely different number. There's something it's not liking. Oh, hang on. Let's see. Did I tick supplies of hot water? One of the downsides of this online program is sometimes it keeps things in the calculation you're looking at.
Is it maybe not recalculated?
Yeah, it's not. There's something that's... And it seems to be a function of the water heating for some reason. We'll give it a cylinder volume. I was using this earlier today, and there was actually another problem that I told them about, not this problem. So the good thing about it being a web service is if things need to change, it happens. You don't get another disk through. The downside is if they're playing with it. There we go. So our TER has changed quite a bit. So whatever it was I was doing, whatever I found that was wrong. So where do we get to? So we got water heating, and I've now made it electric immersion. But let's see if I go back to from the main heating system, we should see an improvement. There we go. So we've seen a bit of an improvement to 22.38 because I've now gone from electric to gas. Wastewater heat recovery units, for those who haven't come across them, these are little heat recovery units that sit underneath the drain to your shower or your bath. And the idea is as the warm water, it works better with showers, but as the hot water goes through your plug hole, your cold mains water comes in and wraps around it before the pipe goes up to the shower, so that your mains incoming water is a bit warmer than it would otherwise be. And it does have a benefit. So we'll stick one of those in, and we'll say this house has got 2 bathrooms, number of mixer showers in bathrooms without a bath, none. With a bath, right, both of them are baths with showers over. We'll select that. We probably need to close this window or move on to the next one. So it was 22.38, and we still are. So I've probably, didn't take for some reason. Right, did I say 2, 0, 2, select.
But will your DER always be higher or equal?
There we go, I didn't submit. For compliance, DER has got to be the same or less. So we're still not compliant. This house doesn't meet the building regulations just yet. We won't put space cooling in. The TER assumptions assume that every dwelling has some solar panels on it. We won't put some solar panels on, but we'll put some photovoltaics on because they're really popular. So we're at a PV panel. We'll call it PV, and we'll give it a kilowatt of peak output at 45 degrees facing south, obviously, and very little overshading. We'll add that. Now, PV helps compliance enormously because you're producing electricity that displaces electricity, which has got the highest carbon factor. So we've managed to get to a DER of 18.55. So in fact, if we edit that and add 2, we now have a compliant building. So we've stuck probably, I think that's probably about 8 square metres of PV on top. So.
And this is only relevant to new build, the DER and the TER?
Correct, yeah. Correct. Last section is the overheating, which again, in Scotland, the output isn't regulated for. And then very final screenshot, because I'm sure you're all getting restless, and I'm just over my hour and a half. We will produce the compliance calculations, and then I'll produce an EPC for this, or what looks like an EPC. An EPC, you must remember EPC is like your MOT certificate. It's what's in the database ultimately, even though there isn't a central register for this at the moment for new builds. It's the information in the registered database that's important, not your bit of paper. Why are they not doing that? There we go. So that's a summary We can do it in one go. In Scotland, the EPC is separated out because we don't provide an EPC at building warrant stage. And this is this happens to be an English calc, as it were. So again, because of the differences between England and Scotland, one of the questions it asks you right at the beginning is which domain you're in, and it has different assumptions. I found one the other day which surprised me, which is the number of fans that it is assumed is in the TER calculation is based on floor area. The number of fans that it assumes for the FEE calculation is based on the floor area, but they're two separate sets of assumptions. I have absolutely no idea why.
Is there anywhere on it you can make an executive sort of summary and put a paragraph in? No?
No. I mean, you can put comments about the calculation at the beginning, but there's no mechanism to add a reality check to it. So that's the thing itself, and that extends to, it's not telling me how many pages, but, so within this we've got, has it got 22? Oh yeah. So we've got sort of basic input information, so a summary of what we've put in. That's our FEE calculation that stops at section 8, space cooling, and that's the number we get from that, energy efficiency calculation. Worksheet for new drilling. Now that's as designed, so this is what the SAP calculation, SAP is based on. So we go all the way down to our primary energy that goes on the SAP calculation, and that's where you get your EI rating, 86B. We've then got the dwelling emissions rating, which gives us a different number because there's some subtle assumptions in there, 15.77, and then we've got our TER rating. And this is where you can see, for example, it assumes for this dwelling that there's 3 extract fans, for example. And will it give us things like the U values for the building fabric probably in there? So yeah, so we've got U values of 2 and 2.5, 1.6, which are taken from, which are the TER targets. And it gives you a different number at the end. And then, what have we got? Compliance list, a summary. Because in terms of your submission for a building warrant, or the equivalent in England and Wales, you could demonstrate that your DER is less than your TER, but you still may fall foul of other bits of the regulations. So you might have one window that's single glazed and unacceptable. I mean, you'd have had to struggle very hard with something else to compensate for it, but you would not then be compliant, not because of your overall energy use, but because of a backstop U value. And there's an English EPC and a recommendation report. The recommendation reports also vary between Scotland and England and Wales. In Scotland at the moment, the only recommendation you can put on an EPC for a new build dwelling, on the assumption that the new build dwelling is compliant, is a requirement to have 100% low energy lighting if you haven't already got 100% low energy lighting. In England and Wales, the recommendations can include things like PV panels and solar panels and stuff like that. So there's solar voltaics, even though we've got some, I suppose. Right. So there we are. That hopefully gives you a taste of the mechanism of producing one of these things.
So to get that off the draft, you have to lodge it on Landmark, yeah?
Yes, in England and Wales. In Scotland, if that was a Scottish version of a calculation, I could just print it out and hand it to building control.
Like a Word document?
Or just as a PDF or print it out.
With draft on it?
No, it doesn't say draft.
All right.
Because there's nowhere to register it.
How would you have got it compliant without dropping PV in the roof?
Well, this will be based on a design that is pre-2009. So the U values in it won't be particularly good, I suspect. So let's have a look at those.
Yeah, because you got it compliant there for dropping a renewable on the roof.
Yeah, the lazy way.
Yeah, that's
Yeah.
what I'm saying. Because what I was picking up from you, every time you make an improvement to an efficiency or a fuel source, it applies that to the target as well.
No, if you improve an efficiency in, say, the wall fabric, so the TER for this calculation will assume that the walls are at 0.25,
Right.
and actually I've got them at 0.29, because this is a calculation that's been in the system for a long time.
But if you move the gas,
Yeah, if you move between fuels, then the TER assumptions change, but they don't. The TER assumptions are pegged to things like the building fabric. So you get a different target, but you also get a different dwelling rating. But if I change the U value of the wall here, for example, it will improve. I'll get an improvement. So if I were to edit all of those to, say, 0.1, which is getting somewhere near...
yeah, it's slowed down the heat loss and then demand on the...
Yes, so I can't remember what DER was before, but it will have improved a bit. So if that's 15...
But your TR is your baseline once you put your...
Once your fuel is in, yes.
In SPEM, the notional building is fueled by gas.
Yes, yeah, for everything, isn't it?
So, yeah, it's assumed to be fueled by gas.
Yes.
You've got a problem there bringing that into compliance. It's very difficult.
Well, it means with SAP you've got a constantly shifting target.
Yeah.
So, yeah, we've dropped TER to 13.37. So I could probably go back to my photovoltaics now
Take them out.
and take them out, or at least reduce them down.
Why on earth do they show micro wind turbines, given how useless they are?
This isn't reality.
I know, but they shouldn't even be there anymore. 'Cause there's- oh.
Yes. So we're almost compliant, and I've just taken out over half of the PVs.
You've still got to keep the PV in there to get it, to guarantee your compliance, that's the point.
Oh, no, not at all. I mean, I'll...
Well, if we take it out, let's see what effect it's got on that.
Well,
reading.
I'll show you a calculation. Now, this is the calculation which I won't fiddle around with, but in this one, you can see that DER is just inside.
Yeah.
And we've got, in this one, we've probably got lower air infiltration, so we've got an air infiltration figure of 6,
Yeah.
which is what a competent contractor can do with a standard timber kit, which this effectively is. It's a timber kit, so the thermal mass will be light. The exposed elements, the U value, this is more representative of the stuff that's being built at the moment. So we've got U values of 0.19 and 0.11 in the roof. So that's 400 mil of insulation in the roof, for example. This is a sort of end of terrace, 3-bed, reasonably square house. The openings are very good. We've got 1.2 windows in here. Oops. Yeah, we're using windows with a U value of 1.2, and even better on the doors. Our primary heating is what appears to be just about the most efficient gas boiler you can get at the moment, which is this Baxi Duotech Combi. In terms of controls, the controls are just room stats and TRVs on this one. The one I skipped over very quickly was our psi values and our overall Y value, which, as you can see, is down at 10 kilowatts per square for the whole dwelling. And the reason for that, reason why it's sitting there with a calculated one-liner, is for this project I did an offline calculation using psi values that were prepared specifically for this kit. So we actually end up with an average low psi value. The only way to really put it in here, because there's not enough options within that list of different junctions, and of course you might have 2 type of wall junctions and then you've got to munge them together. So I find it much easier to do it on a separate spreadsheet and just put 2 numbers in and write an explanation to building control. So our thermal bridging is very efficient because we've calculated, not because we've made it any better. And that's been a big part of making this project actually work. So this is a project where a developer said, look, this is my standard kit. This is what we've been doing up till now. What do I need to make this comply? And the first step was to calculate it more thoroughly. And we played around with all sorts of things like wastewater heat recovery and flue gas heat recovery and increasing thermal performance greater and then putting PVs on the roof. And from an economic point of view, none of those really made sense. What made sense was buying a very good boiler and paying £2,000 to calculate the thermal bridging calcs. So I think I'm 15 minutes over now, so apologies to the next speakers. But unless there's any more questions, I hope that's been of use. Thank you very much.